So if we can look at what happens with the life of a glass, and we can just see what the impact is then of the reliability of a glass. What I've got here is a situation. We have glasses from around the world. We'll just say the manufacturer of the glass made 1 million glasses. 1 million glasses, and they're in 12 packs. So I go to the store and I buy a pack of 12, which means there's 83,333 households with glasses, with a pack of 12 glasses. Now, in my house, when it comes to breakages a year of a glass, we break about two a year. In your place, you've got young kids, have you?
Grandkids.
Grandkids, okay. Any idea of what an average breakage of glasses in your place would be?
Greater than 2.
Greater than 2, yeah. And yourself, Bruce, with
Just only 2 of us, so we hardly ever break a glass.
Yeah. So it depends on the situation. Depends upon the families and how many kids, how many opportunities there are for these things to break. So I'll take the figure 2 because that's sort of a reasonable number to work with. So we can say in these 83,000 households, about 2 a year. So 167,000, 667 per year would break around the world. So I can then take that information into a plot. And if I just say, let's just break this into 6-month periods, 12 months, 24, 36, 48. There's a few things we can say about this situation. On day 0, the very first day that people get their pack of 12 and bring it back to the house, there's going to be, they're going to take them out of the pack, they're going to put these onto a shelf in their household. From your experience with breaking glasses, do you think out of these 83,000 households, some of those will break that glass at the very first time they pick it up, go to stack it in the shelf? So our failure rate at the beginning will not be 0, it'll be some number above 0. I've got no idea what that number will be. I'd have to survey all these households and ask them, but I'm guessing 100, 200 around the world would break. Now, after 6 months, we're going to be using the glasses. There's going to be friends visiting, there's going to be the kids coming across, the neighbours' kids come over for drinks, we've got birthday parties. Things begin to happen that use the glass. So that failure rate, because they are now being used, is going to be happening. Things are going to start breaking. And as the year goes by, again, more opportunities. There'll be Christmas, there'll be New Year's, more festive seasons happening. You're going to find that then, of course, the years begin to repeat. And year after year, similar sorts of things happen. Occasionally you're going to have the big party, the 30th anniversary, 25th wedding anniversary, those sort of things occasionally going to happen. So you're going to find that the curve over time begins to level out because the opportunities just keep repeating. And as I say, about 2 glasses a year on average break in my household. So what we can say from a family of 1 million, if we divide this figure here by our million, we get 0.167 is the average failure rate of our glasses across this population around the world. So this line here now becomes that particular value there. And the assumption is that it's continuous. That line will be pretty much the same, at least in my household, forevermore, because the opportunities keep repeating and 2 a year on average tend to happen. Once I've got an equation for that line, I have now got a way of projecting the future. So I can say between years 2 and 3, if every household across the world that has these glasses had an average of 2, then every year I need to replace them with about that many glasses every year across the world. So the manufacturer of these glasses will know he's going to make that many glasses a year to replace. In my place, so when it comes to stocking those, I can say, well, every year I've got to buy 2 more of these to replace the ones I'm going to break in the coming year. So I can now develop a stocking policy, a resupply policy. I can work out roughly how many glasses is going to break in the coming 4 or 5 years, what that will cost, projecting it forward because I've got a stable failure rate of those glasses. So from this information, I've got a curve representing the history of the glass. That will be the same as the future, assuming nothing changes. So I've now got an equation to predict the future. And reliability engineers, that's their job, to give us equations of the parts we use and when they fail to predict the future of these parts. Very powerful logic, very powerful stuff. For a maintenance guy, having an equation of the future failures, fantastic. You can begin looking at strategies, procurement, sparing, dealing with subcontractors when to bring people on site, when to begin maintaining machinery. So very powerful technique. So I'm going to put this now into the presentation. Opportunities, of course, they are there. Now, doesn't mean they're going to break a glass at every opportunity. The thing is, the glass will only break when the opportunity is there for it to occur. So in my festive seasons. Now, when you look at when each or why each failure happens, we can say, well, over that time, we're going to drop glasses out of our hands. So I've had 3 droppages in that period of time. Then occasionally a glass gets knocked. Then occasionally a glass gets stacked badly. Stack a glass and it gets cracked as it's stacked. And there's reasons, in this case it's on a tray, the tray got knocked and the glass falls off a tray. So we can begin looking at the reasons for our failures. So this curve, the curve that we came up with, 0.167 average across that family of 1 million glasses, that curve here is a result of the sum of all the failure causes. So in our machines, the curve for our machine is the sum of all the parts failure causes.